Let's take a look here at how we would do dividing and multiplying for rational expressions. And again, remember that rational means things with fractions. Okay, so let's do with numbers first, because it's always a good idea to remember how to do this like normal. Remember if we had something like 3/5 times, say, 10 over 11. But if we were going to solve something like this, we could say, well, there's two ways we could do it. We can say, okay, well, it's 3 times 10 over 5 times 11. So that's 30 over 55. 55? Yes. Then I might say, okay, if I divide the top and the bottom by 5, I could get 6 over 11. So that might be the way that you think about doing it. Another way you could think about doing it is to recognize that 10 is the same thing as 5 times 2. And then coming in here and saying, okay, so since I have a 5 on the top and a 5 on the bottom, I can cross those out, and then I just end up with 3 times 2 over 11, which is 6 over 11. And that's essentially what we're going to do with rationals. So let's say we've got something like this, x minus 3 over x plus 5 times 2x plus 10 over x squared minus 9. So what we want, well, actually, before I get too crazy, let's go ahead and make this thing on the top just 1. That'll be a little bit better. Woo. All right, so let's try something like this. Now, ideally what we want to do is go ahead and factor everything out. So I can say that's a x minus 3 over x plus 5 times 1 over, and I recognize that this here is the difference of 2 squares, so I can factor that as x minus 3, x plus 3. Okay? So since I have an x minus 3 on the top and an x minus 3 on the bottom, and everything's being multiplied by everything else, I can go in here and I can cancel those out. So then I end up with 1 on the top and x plus 5 times x plus 3 on the bottom. And that is a simplified version of the original problem as stated. Okay? So let's add a little bit more from now. We'll actually do the problem I had written earlier. X plus 5 times, say, now we'll do the 2x plus 10 and the x squared minus 9. So again, we can see I have x minus 3 over x plus 5. Now on the top, I can factor out a 2, and if I do, I'm ended up with, if I take a 2 out of 2x, I have an x. If I take a 2 out of plus 10, I have plus 5. And on the bottom, again, we have the difference of squares, so x plus 3, x minus 3. Now, if it helps you to go ahead and write out the full multiplication, you can. If you want to write it all in the same expression, you can say it's x minus 3 times 2 times x plus 5 all over x plus 5 times x plus 3, x minus 3. And if that helps you see what we're doing a little bit better, that's great. If you don't want to take that step, you don't have to. You can either come over here and you can say, okay, so the x plus 5's on the top and the bottom. And since I can only do this because everything's being multiplied out, then I have an x minus 3 on the top and the bottom. So you can cross those out there, or as an alternatively, you could come in here and you could cross them out here. You could say x minus 3 crosses with that, and x plus 5 crosses with that. In this case, you'll end up with this. In the previous case, you'll end up with the exact same thing. So it's just an issue of if you want to actually write it out. 2 over x plus 3. Okay? So we can give you all kinds of problems like this, and really just one of those things, the more you do it, the better you get at it. So like 25x over 2 times 1 over y cubed. Now in a problem like this, there's really not actually a whole lot you can do. In fact, there's nothing you can do. It's 25x times 1, which is just 25x, and then 2 times y cubed. Nothing cancels out, so don't feel like every problem you have to force something to cancel out. Just be kind of prepared for doing whatever is necessary to get the problem done. So let's try something a little more interesting. And go ahead and see if you can work this problem out on your own, because that's how you'll know if you can really do it. All right. Now this is where it's important to remember some of your exponent laws. So we'll do a quick aside. Remember that if I have something like x to the n over x to the m, that reduces to x to the n minus m. So like if I had x to the, let's not pick problems, yeah, there we go. It's like if I had x to the 7th over x squared, then that would come out to x to the 5th. That also kind of works in reverse. So if I had x squared over x over to the 7th, I could make it 1 over x5, and that would be fine too. Okay, so make sure you remember this kind of stuff for solving these problems. It's really important. Okay, so I'm going to add a room over there, so I'll just write it over here. So if I can either multiply everything on the top and then reduce, or I can reduce first. I like to reduce first where I can because it means that there's less that I'm going to have to multiply later. So I know that 7 goes into 14 2 times. So I can cross off the 7, cross off the 14, and replace the 14 with a 2. And that's okay. I can also see that I have an x squared on the top and an x squared on the bottom, so both of those are going to cancel out. Now, I'm going to go ahead and just rewrite this because I'm getting too much stuff going on and I just don't want to mess up anything. So now I have a minus sign, a 3y to the 5th, and on the bottom I have a 10y, right, because it's 5 times 2 times y. Alright, now I can recognize that y to the 5th over y is going to reduce to a y to the 4th on the top. Because I have 5 up here, remember my secret exponent on the bottom would be 1. So y to the 5th divided by y is going to give me y to the 4th up on the top. Funsies? Alright, let me give you a couple more. And go ahead and see if you can work these out on your own before you watch the video, because that's how you're really going to know that you're learning it. X squared plus x over 3x, and while you're at it, go ahead and try 3x plus 3 over 5x minus 5 squared, and that 5x squared, and that one's actually a lot harder. So go ahead and try those and see if that makes sense to you. Okay. Now, assuming that you've done that, recognize that on the top of this problem you can factor out an x. If you do, if you pull an x out of x squared, you have an x left over. If you pull an x out of plus x, you have a placeholder of plus 1 left over. Since I'm multiplying everything by an x on the top and multiplying by everything by an x on the bottom, the x's can cancel out, leaving me with x plus 1 over 3. Good? Okay. So now go ahead and try working some of these problems on your own, just to see if they actually make sense to you. X squared plus x over 3x times 6 over 5x plus 5, so try that one. And then down here, this one's a little bit harder. Try 3x plus 3 over 5x minus 5x squared times 2x squared plus x minus 3. I told you it was harder. Over 4x squared minus 9. And again, the reason that you're doing this is because all math is about trying to take a problem that you don't know how to solve and turning it into something that you do know how to solve. So eventually we're going to do something like this and say solve for x. So the first step in solving that problem is to be able to simplify this complicated problem using the multiplication and the canceling out strategies. So let's assume you've given these a shot on your own, remembering that the very first step you want to do is you want to factor everything out the best that you can. So if I pull an x out of x squared plus x, if I pull an x out of x squared, I'll have an x left over. If I pull an x out of plus x, I'll have a placeholder of plus 1. Alright, now if I'm multiplying 6 over, I can pull a 5 out of here. If I pull a 5 out of 5x, I have an x. If If I pull a 5 out of plus 5, I've got a plus 1 placeholder left. Since I'm multiplying by an x on the top and the bottom, I can cross those out. Since I'm multiplying by an x plus 1 on the top and an x plus 1 on the bottom, I can cross those out. Finally, I have a 6 and a 3. I know that 6 divided by 3 is 2. So actually, basically everything cancels out. The only thing I have left is a 2 on the top and a 5 on the bottom. So 2/5. Got it? Good. All right. So hopefully you got that one. Now this one, if you struggled with, that's completely understandable. This is a much more involved problem. So remember, our first step is to factor. If nothing else, don't give up, because you want to take a problem you don't know how to solve and turn to something that you do. I don't know how to solve this. Looking at this, I do not know the final answer, but I know that if I take enough steps, I will eventually get there. So don't be worried about step 345 when you're on step 1. And step 1 is factor out what you got. So I recognize that I can factor a 3 out of this here. And if I do, I'll wind up with 3 over x plus 1. If I factor a 5x out of there, if I factor a 5x out of 5x, I have a 1. If I factor a 5x out of minus 5x squared, that gives me minus x. And if I'm not sure, I can always go redistribute it. 5x minus 5x squared. Okay, so that worked. And there's completely nothing wrong with checking your work, and it's in fact quite advisable. So maybe you didn't get this far, and if you didn't get this far, go ahead and see if you can do it. You know, pause the video, see if you can figure out what these factors are if you couldn't remember what the first step was. Okay, so here my factors are going to be 2x and x. This is going to be a 1 and a 3. Since this is minus, that means my signs are a plus and a minus. I'm not sure which direction they're in, so I'm just giving it a shot. If I go 1 and 3, my outer is 6x, my minus 6x. My inner is plus x, which is 5x. That's in no way right. So let's move the numbers. Oh, wait. I think that's what I just had. I forgot. Maybe I'm not generally good at stuff. Come back. So let's do 3 and 1. Alright, so outer, minus 2x, inner, plus x. That gives me minus x, so the number's right, the sign's just wrong. So I gotta switch those. So I had a plus and a minus. I'm gonna make it a minus and a plus. Outer is 2x, inner is minus 3x, so that, wait. Did I just replace it with the exact same thing, or do I just fail at math in general? Try this one more time. Plus and a minus. Minus 2x plus 3x. That equals positive x. Whew! Alright, I swear I know how to do this. Okay. Some theories of teaching think that you should let the students see you suffer because it means that you're like human and stuff. I don't know. We'll see. Do you feel like I'm more human now? So this, believe it or not, here on the bottom is actually a difference of squares. It's a little hard to see, but if you take a look at it, this is actually 2x quantity squared minus 3 squared. Write that in a different color so you can offset it a little bit. Right? This is 2x squared minus 3 squared. So since it's the difference of squares, I can write it as 2x minus 3 and 2x plus 3. So there's a lot of really weird things about this problem that make it interesting. Okay. So now what I can do is I can actually start messing around right now. 2x plus 3 crosses out with a 2x plus 3. And quite frankly, there's too much going on here, and I'm just going to rewrite it. I can always cross off more stuff later. Over 5x times 1 minus x, and I still have an x minus 1 on the top, and a 2x minus 3 on the bottom. Okay. So looking at this, this should really call attention to itself. You should say, there's something here I should know. How could these really factor out? And you might recall from a previous lecture, if you saw it, that we can actually factor a negative out of one of these. So let's see what happens. I want to factor, if I factor a negative 1 out of x minus 1, I'm going to end up with minus x plus 1. So basically, factoring out a negative means you switch all the signs. So if you're not sure, go ahead and distribute it. Minus 1 times minus x is plus x. Minus 1 times plus 1 is minus 1. That's x minus 1. That's the same thing I had. All right? Now, I have the same thing on the bottom. Now what you can do, I'm going to go ahead and pull that negative there, x plus 1. Now, minus x plus 1 is the same thing as 1 minus x, right? Because it's, negative x plus 1. Since it's adding, I can switch the order. And 1 plus a minus is the same thing as 1 minus. So that's where I'm getting that from. And now I'll go ahead and fill all this in. And lo and behold, see the 1 minus x cancels with the 1 minus x. And we'll go with this over this. And this is a pretty exhausting, emotionally exhausting problem. And so if you need a break, I would definitely take one. We'll come back and I'll post another video that actually talks about doing the dividing.